Okay, so we want to finish our 1, 2. We just barely got started on Monday. And yeah, we're going to intro a little bit of what the kind of again, talk about it. You know, Monday, do 1.3. And the quiz is going to be on 1.2 only. 1.2 only. I will tell you exactly, it's going to be 2 problems. And I will tell you exactly what I'm going to ask you today. You'll have 1 question like this, 1 question like this, based on the homework. Okay. And then continuing on next Wednesday with 1.4. So, talk about what the slope is going to do. And mathematics, the driving force of mathematics. What calculating or doing math is all about, finding rate of change. Slope tells you when things increase. If it's positive, something is different. Slope tells you when things decrease. So negative than that, things decrease. If it changes from increasing to decreasing, it reaches a maximum value. If it changes from increasing to decreasing, it reaches a maximum. If it changes from decreasing to increasing, the minimum, which is the bottom. That's the whole purpose in business, in physics, in medicine. When is this medicine? When is this, drug reaching its maximum efficiency or efficacy, work within the body? When does the actual side effects, or when does the potency of the drug reach maximum, and when does it start to taper off? When should you take the next dose? So you collect data, and you notice that whatever the behavior that you're measuring, scientists measure increase in what's happening with the reaction from the drug. And then you see at some point, you don't know if it's maximum enough, but at some point you see that it starts to, my pain is going away, I feel a lot better. Oh no, it's coming back, it's coming back. So at some point in time, it reached some maximum efficiency. Now you can't take another pill right at that maximum and continue. So you have to figure out when can you collect data and you want to curve the best fit the data. That's what statistics do. Every major you have these days involves statistics, whether it's sociology, psychology, all the liberal arts are trying to do statistics. Now, if you're a writer, maybe not. But if you're a writer who is trying to be credible and you're trying to write something maybe science fiction or even fiction, you're going to want to be credible if you're talking about something that has got a sign then. Or even, not even science, how about just voting? How about just, what's going on in the world today in terms of politics? So much of it. People can make statistics say whatever they want. But the bottom line is statistics is mathematics. You collect data and then you find the best equation that fits the data. You can use those equations to predict what will happen in the future. That's what collecting data is all about. Slope helps us predict. In calculus, it's about figuring out based on taking the slope at instantaneous points that pointed out on Monday. When does a function reach a maximum or a minimum? If you're a business, at what point do I need to stop making the product because I'm going to reach a maximum profit? I can keep making the product saturated with all my products. Nobody's buying them anymore. I'm sitting in the warehouse with a whole bunch of, factory boys out there. And nobody's buying them. Because it's saturated the market. This is what happened in the early 90s with baseball. Everybody and their mother were making baseball. So the whole market gets saturated. And they're not just making baseball, they're making lots of the same thing. So what drives a baseball card collector? Because they want something rare. I'm the only one that has this, or I'm just one of 25 that have it. Then it's worth something to those people. But if there's 300,000 Barry Bond rookie cards, it's not worth much, even though he may be a really good player and his rookie card should be worth much. There's too many out there. And they have the commons. They almost destroyed the market in the early 90s because they were making too many of the same thing. And they were being bagged, put in the plastic bags. So if you actually opened it out of a little plastic bag, it's not worth less. So if you wanted to read one, you had to buy two, so you could open one to read it, and then one that wasn't. What was smart on their end, but it destroyed the market and no that. You know that Marvel went into bankruptcy in the 90s. That's why they didn't own the X-Men. They sold the box. All the characters together. Just didn't get money. Now they have the right back. Anyway, in the early 90s, there was an artist by the name of Rob Liefeld created a little character by the name of Denver. At that point in time in my life, I was buying two of everything, and it was an X-Men fight. I think because nobody knew what that was. They didn't make a whole lot of it. And not a lot of people buy it. So I've seen it, behind counter at bookstores for $800. Yeah. Another person that I know on this campus was me. I don't plan on ever selling. I have it in my will, theoretically, that if when I die, the family can sell my book if they read every single one first. And I think it's somewhere over 40,000. I lost it. But is, you know what slabbing a book is? You sit it up to the company, and break it, and then put it in plastic slabs, so it can never be opened. So it's vacuum sealed, and it's got a certified rating of anywhere from 0 to 10. Okay. Then you know that it's in pristine condition, but if you open it, well, you have one of these first edition Deadpools, and it came back like at a 9.8 grade. So from $800, that thing goes up to $4,000 because it's rare. Now here's the deal. Mathematically, you cannot predict what's going on in the baseball card market or in the comic book market because it's built on emotion of what people like and love and all the other things. Emotion plays in. I don't think math is going to ever predict emotion. When it does, the nerd's going to win. Bottom line about slope. Start with lines first. So, and I pointed out to, Tuesday, Thursday is basically like a day ahead of you guys because they didn't have a day off. It may look like I'm just reading this stuff to you. What I'm trying to do is I'm trying to walk you through what would happen. Two scenarios. You're absolutely not necessarily this time. Any math class, any science, physics, whatever. Or I remember one semester I had the worst math teacher I've ever experienced in my entire life. Never looked at the class, always back to the class, back. And when they turned around, eyes were up to see. So you could have your hand up in the class and they would never see it because eyes are up to the ceiling. So you could be sitting there waving your hand, wanting to ask a question, they just kept talking, and turn around, back. First day, there's like 45 people. The next week, there's about 18 left. Because they realize don't have to go to class. One class is monotonous, worthless, just going to kind of read. Trying to read a math book that level is not easy. If you're in your faculty on your own for the last year and a half, having worked from home, can't sit there staring at a computer. You need it. Mathematicians don't write this stuff. A basic student can read it and know what's going on. If you're speaking a language that they expect that you already know all the vocabulary. And if you don't know all the vocabulary, you can't speak at their level, you're trying to read it up here, and you're down here, and it's just like, might as well be written in French. So Latin. I'm trying to break it down how you can make that connection. Eventually, we'll just go through page by page. Right now, I just want to show you that it is important every now and then you open up the textbook or you pull it up or whatever. And you look at how is this written down and what language is speaking. This is typical. This is in every algebra. Slope is rise over run. Slope goes to 2 points. It's the difference in the y divided by the difference in the x. Difference means subtraction. It's the change in y divided by the change in x. Okay. Change in y over the change in x. So when we have slope and we use the letter m, use the letter m for slope when we're dealing with lines. The slope is the rise of a line or the run of a line. So you're starting at some point over here, and you're going to some point over there. The rise is how much do you have to go up? That's your rise vertically. And the run is how much you have to go across to get to that point. The run is across. So it's a fraction, a ratio of the rise and the run. What's the change of the y value over the x value? So the rise is the change in the y value divided by the change in the x. Now, mathematically, this symbol is the symbol for change. Yes. It's actually a letter. That is actually a letter. Delta, capital Delta, Greek letter. Go past the frat houses in Fresno State, You'll see those on the houses. That's delta. Delta. Uppercase delta. And that's lowercase delta. So delta is change. If you're in chemistry, you'll see delta T. Change in volume, you'll see delta T over delta T. What's the change in volume divided by the change in temperature? If temperature increases on a gas, the gas gets excited, so pressure goes up. If the temperature goes down, then the gas is slowing down, the molecules kind of relax a little bit, and then pressure goes down. But delta is the change. When you make change, if something costs $3.40 and you give the guy a 5, the change is subtraction, $5 minus $3.40. So change is subtraction. So you subtract the y value, you subtract the x value. So that change in y, so you have, this is your first point, x sub 1, y sub 1, and this is our second point, x sub 2, y sub 2. So it's that y value, y sub 2, minus this first y value, y sub 1, over this x value, x sub 2, minus this x value, x sub 2. Change in y or change in x. Now, make sure you understand I'm saying y sub 2. Y subscript. It's a subscript. You have a superscript that we want 3 squared. That's a superscript. It's up here in the top corner. That's a superscript, like Superman's going up. A subscript, like a subway, is at the bottom. Neatness counts. This is not y sub 2. That's like a 2y. Trust me. Remember, it's a language. When you write, you expect to be understood. Just because you understand what you write does not mean the person who's grading your paper will understand. Just count. How important is this? Slope is the change from where you are minus where you were. Divided by how long it takes you to get. So here's the story I tell every single time. It really makes an impact. More importantly, I do get these calculus when they don't solve all the calculus problems. But I thought I was some kind of superstar when I was in college in UCLA. And I made it from my apartment home in Fresno in 2 hours and 59 minutes. I broke the 3 hour. I thought, wow, I can try. I got LA to Fresno in less than 3 hours. So I got going. She got from our house in Fresno to my brother's house in Burbank, which is 200 miles, in 2.5 hours. 2.5 hours. Now it was at night. It was like we think we left like at 11, so we didn't have to deal with that. If you got full traffic, then you're out. It would take 2.5 hours to see through. Burbank is at the north side of it. But that I think about this. Miles per hour. I removed this thing off because I found out that probably shouldn't record this. I just don't know what the statute of limitations are. She went 200 miles in 2.5 hours, so 2.5 hours. I told you on Monday that miles over hours, the change in distance, not change in time, is just the average slope of the trip there. So basically, here's what happened. Where am I? I was at my brother's house, 200 miles away. Where was I? Where I am minus where I was. I was at home, which is the starting point at 0. When did I get there? I got there 2.5 hours from now, 2.5 hours. When did I start? When the clock said 0. That's the bottom line. Where you are minus where you were, divided by how long it took you to get there. If you take 200 and just divide by 2.5, you know what that equals? It's just 80 miles per hour. Now, who hasn't driven 80 miles an hour on the freeway? And if you say you, you're lying. Everybody. Huh? Who says you've never driven 80?
I've gone over 80,
Yeah.
all the way to LA.
Yeah. But here's the deal. That's the average. Where you are, where you were, that's the average speed that you drove all the way to LA. What that average means is from backing down our driveway, 80 miles an hour for the entire trip, 80 miles an hour. Going through our neighborhood, 80 miles an hour. Sitting at a stop sign, 80 miles an hour. Going through Starbucks, 80 miles an hour. For every part of the time for the 2.5 hours, it would have been 80 miles an hour to average 80 miles an hour. Or some of the time she's above 80, some of the time she's below 80. That's how you get that average. Now, here's how these things actually work. In calculus, there's something called the mean value theorem. Mean is average. When you take a mean of something, the mean of all your test scores, you take the average of your test scores. Mean is average. The mean value theorem means this is an average velocity, an average speed. The instantaneous velocity at some point in that 2.5 hours has to be exactly 80. If your average velocity is 80, then somewhere in between you had to actually be going 80. Maybe at least once, maybe twice, who knows? But there has to be at least one moment in time where you actually did 80 miles an hour, unless you went through a wormhole. Okay. This is how they can give you a speeding ticket when they say your speed is monitored by an aircraft, by a plane. The plane is not zooming in and hovering over you and then trying to match your speed. First of all, a plane is flying in knots, nautical miles per hour. Okay, so they're not measuring miles, they're measuring nautical miles. Because they have wind resistance, all those other things. So what they do is, on the road, the plane can spot maybe an intersection and another intersection. The plane knows the distance between those two intersections. All they have to do, maybe a stopwatch, I don't know, is time how long it takes that little red car to go from one marker to the next marker. The landmarks. And if the average rate of speed between here to here is over the speed limit, then there had to be one moment in time in between there where they were going over the speed limit. So then the plane lands in front of the car, land in front of the car. They radio ahead to a police car, highway patrol, sheriff, whatever, and they tell them this guy was speeding, pull him over. That's how they monitor from the air. These days, I'm surprised that this hasn't happened yet. Your phones have GPS in it. Somebody knows where you are and when you are all the time. So if I go from point A to point B faster than the speed limit, they could give me a speeding ticket if I'm in a car. I'm surprised they haven't done that. Because they got to, boost up the revenue. I don't know. Who knows? Maybe it's coming. Radar gun. The radar waves travel at the speed of light, electromagnetic waves. It hits the car and then it bounces back. That radar wave measures the distance from the patrol car from the gun to where the car is. And then it sends out, the car's a little closer, it sends out another one and it bounces back. And they know this second distance. So then the gun can figure out what was the change in the distance, that delta D. And because it almost happens instantaneously, it is happening on speed of light there, but it's still not instantaneously, but it's pretty close. They can get a really good instantaneous what speed going exactly right now. But it's still taking readings to different distances divided by a very minuscule change in time. That's how the radar gun works. It's all about slope. Change of one thing divided by change in another. Now, it says right here, x sub 1 and x sub 2 cannot equal each other. Because if these two are equal, 5 and a 5, then you get 5 minus 5 and you're dividing by 0. And you're not allowed to divide by 0. You divide by 0, it's undefined. So something to remember so we don't get them confused. When you have 0 divided by a number in the numerator, any number goes into 0 except 0. Any number besides 0 goes into 0 exactly 0 times. So 0 in the numerator is 0. If you have a number and you try to divide by 0, except 0. So 0 going into any number besides itself is impossible. It's undefined. There's no real number value for it. Now, you will come across possibly this. 0 divided by 0. So here's the problem. 0 in the numerator, we just got done saying that's a 0. So it's supposed to be 0. But 0 in the denominator, hey, when 0 is in the denominator, it's supposed to be undefined. So this is supposed to be undefined. Okay. But anytime you divide something by itself, like 5 over 5, 3 over 3, -2 over -2, you should get 1. 0 should go into 0 one time. So that answer, it should be a 0. It could be a undefined. It could be a 1. If it could be all 3 of those things, then you know what? I don't know what it is. So the answer here is I don't know. No, it's indeterminate. Which means I don't know. It can't be determined. It can't be determined. Sometimes the answer is 7. Sometimes the answer might be -2. Sometimes the answer might be 0. 0 over 0 happens when you take the slope at exactly 1 point on a curve because you're letting the numerator y equal y, the same y minus the same x's. This y and that y are the same thing. This x and this x are the same thing. This is what Isaac Newton kept running into. So you can't divide 0 by itself. Therefore, instead of dividing 0 by itself, that's where he tried that whole thing about, I'm going to let one point approach the other point. And that whole idea of the word limit. If we let one approach the other, then what it's approaching will be the same as what it equals if I could let one point equal the other. And that's how calculus works. So that ends up happening in calculus all the time. That's a driving, question that had to be answered. But it came up with this. Right now, for us, we're just going to be putting in the term. All right. I'm going to put it on the slope of the line. That. And more examples. There are four different kinds of slopes. There are 4 kinds of slopes in the line. No. Lower the light. I'm sure that's a little bit there. So there's 4 different ways you can actually draw a line. You can draw a line from left to right, left to right, a line that goes like this. So as you go from left to right, the x's are getting bigger to the left, from left to right, the x's increase. And the y's, as you go this way, the y's get bigger. Maybe this y over here is a -2, a -1 is a 0. But as you continue that way, the y's get bigger. 1, 2, 4, 12, whatever. And the x's get bigger. So this line, as it goes up this way, we say that this line rises. If it goes up to the right, the line rises. That's how you describe it. No. That's linear inequalities. We ain't there. If the line goes this way, down to the right, so up to the right, down to the right. So again, we're always going to look at it from left to the right. So x continues to get bigger. So x is -4, -3, -2, x is 0, x is 1, x is 5, whatever. But the y's, as you go from left to right, the y's get smaller. Y is a 10, y is a 6, y is a 4, y is a 1, y is a -1, y is a -5, y is a whatever. If it looks like this line falls as you go from left to right. So we have a line that rises, a line that falls. Now, in between rising and falling is what kind of line? Well, all the lines are straight. Got special name. Horizontal. Horizontal. So from left to right, Again, X is getting bigger. Okay, X gets bigger as you go to the right, but the Y value doesn't change. It's straight across. Horizontal line. Now, horizontal. People confuse which one's horizontal, which one's vertical. If I make a capital H, like a goalpost, has a little crossbar that looks like a left to right horizontal line. So horizontal goes left to right. That's where we get the word horizon. Horizon is when you look out over the horizon, it's going from left to right, going across. Okay. And so rising, falling, horizontal, the one that's missing is vertical. Vertical is straight up and down. Vertical, from left to right, X doesn't change at all. There's no change in the X. Y is changing. Y is going up, -3, -10, -5, -3, +0, just 0, 1, 12, 47, but Y is changing, or Y is decreasing. It doesn't matter. The Y changes, but X doesn't change at all. Vertical. How do I remember that the vertical goes up and down? Well, look at the V. The V is a little bit like an arrow pointing down, so the other one must be the direction be up. I just try to figure out one kind of little connection to help people remember, because I know you may not be that student, but I've taught Math 103, the Algebra 2 course at this level, for so many years, and those students, they haven't seen math, or they never actually bothered to learn it when they did take it. And they're confused as heck. They don't know one from the other. And I try to give them something they can latch on to. That might make a difference. So if it seems like, why is he talking like we don't know this stuff? Well, that's because my brain is also stuck in how I always do. So I don't mean to offend or belittle anybody. It's just what my brain does. Not offend or belittle people. It's how I explain it. Makes a difference. All right, like I said, 4 kinds of slope for a line of right. So you're going to go from one point to another point. The slope is rise over run. Not even going to do numbers yet, just rise over run. And I'm telling you right now, it doesn't matter if I go from this point to that point, from the one on the right to the one on the left, or if I go from the one on the, just these says that, the one on the left to the one on the right, or if I go from the one on the right and go this way, the one on the left. What? The rise. The rise is up. Up is a positive direction. The run is to the right. If you go to the right, that's a positive direction. So the slope of a line that rises would be a positive over a positive. So the slope of this line has to be positive if it rises. The slope has to be a positive. That's what we use in calculus to determine if something's increasing. If the slope at that point is positive, it increases. Now, like I said, I can go from this one on the right and go to this one on the left. If I do that, I would have to go down first. So my rise would be a negative because I went down. And then I'd have to go to the left. When you go to the left, that's a negative direction. So the run is negative. Therefore, a negative over a negative is still a positive slope. So it doesn't matter which point you start with. when we do this equation, slope equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. It doesn't matter which y coordinate you start with. Just because one point is listed first and then the other one is listed second, it doesn't matter that this one has to be x sub 2, y sub 2. This, you can put this one first.
Wait, why is it negative over negative equal positive?
If the signs are the same, when you multiply or divide, it's a positive. So negative times a negative, that's a positive. A negative divided by a negative is also a positive. So if that's a positive slope, guess what this is? It'll be negative. Let's see. So slope again, rise over run. I'm going to just randomly pick a couple of points. To go from left to the right one, I would have to go down first, which is a negative direction, so the rise is negative. And then I would have to go to the right. Going to the right is a positive direction. So the rise is negative, the run is positive. Negative divided by positive would be a negative slope. If we go from right to left, if we started here and went to that one, the rise goes up, and that's a positive slope, or positive direction, and the run is to the left. That's a negative direction. So your rise is positive and your run is negative. So the slope is still going to be a negative value, no matter what. So if the line falls, the slope is always negative. Okay, when it's horizontal. This time I'm going to use some numbers just to kind of simple. So what keeps this line horizontal is this fact. Or pairs. Maybe this x is negative 8, and the y, let's make the y a 5. To keep it horizontal, the x is definitely changing. Maybe this is negative 3, but the y has to be a 5. Right here on the y-axis, x would be a 0. To keep it horizontal level, the y would have to be a 5. Over here, maybe this is a 4 horizontal, the y would have to be a 5. And maybe over here, it's way over there, maybe it's at like 11, but the y would have to be a 5. To keep it level horizontally, the y's have to be the same number. So when you calculate your slope, that rise over the run. And I'm just going to pick randomly. I'm going to use this guy and this one over here. The rise is the change in the y. This y is a 5, and then I go over here, and this y is still 5. How much up and down did we go?
0.
We went 0 up and down. We didn't go up and down at all. But the run, if I'm here at negative 3 and I want to go all the way over here to an 11, how far is it? 14. That's a distance of 14. 0 divided by a number is 0. A horizontal line, the slope is 0. If I went from right to left, it would be 0. And if I go to the left, it would be a negative 14. It's still 0 divided by any number besides itself is still 0. Horizontal lines always have a slope of 0. Now here's something important. You can't spell the word horizontal without an O, and the slope is 0. Remember what it is. Those people confuse it with the next one. What maintains this line's vertical orientation is the fact that the x's have to be the same. So let's make this x a 4, this y is a 8. This x would have to be a 4 because it has to be directly under. And maybe this y is a, I don't know, 4. This would be x is a 4, y is a 0, -1, and, or sorry, oops, 4, -1, and maybe this is +4, and -12. But the x's have to be the same number, so the points stack vertically above each other, one above the other. All the x's are the same thing, no matter what. So when you try to do slope, that rise over run, I'm just going to pick a couple of points at random again. Let's go with this one. And let's go all the way down to these two. So from this point up here at 8, all the way down to a -12. And we're going to go down. So what is that rise? What's the change in that line? -20. Because you went down. Now, if you went up, it'd be +20. That's just a matter of direction. Over the run, the change in the x's. Well, this x is at 4, this x is at 4. So how much did it change left and right? 0. There's no change in the x's at all. There's no run. Therefore, look what we have. A number divided by 0. And a number divided by 0 is undefined. A vertical line, no matter what, the slope is always undefined, because on a vertical line, the x's would have to be the same value. And if you're doing the slope, y sub 2 minus y sub 1 over x sub 2 minus x sub 1, your denominator, these x values would be the same x's. So you would always be subtracting 4 minus 4 in the denominator, you'd always be divided by 0 for vertical. So vertical lines, always undefined, horizontal, 0. Slope equals undefined. Maybe I got something, hopefully, for other students to remember what this is. Alphabetically, T, U, V, W. Alphabetically, guess who was next door neighbors? U and V. V for vertical, U for undefined. They like to hang out so much with each other, vertical lines have an undefined slope. Over here, horizontal, you can't spell horizontal without an O. Slope is 0. That's the one that goes with horizontal. Whatever it takes for you to remember which one is which, because when you get them confused, these two are the easiest problems to do, but if you mix one up with the other, you don't have a chance. No chance. Okay. Now, the equations of lines that I'm going to put over there, the last two equations that I'm going to put over there, there's 5 of them. I'm going to hit the last two. I'm just going to describe them over here first because I have it up here for me. So I'm not going to waste it. So there's going to be 3 ways to write the equation or line above it. And then there's 2 at the bottom, and I call those special cases. The special cases are these guys right here. Horizontal and vertical lines are special cases. When we write the equation of a line, and we talked about this when we first did section 1.1, and we looked at the function, linear function f of x equals x, and I mentioned this thing, I think I did. If I didn't, then I'll mention it today. If you have a function that has an x to the first and a y to the first, you'll always get a straight line. A relationship between an x and a y, x to the first and a y to the first, you're always going to get a straight line. It's linear. Okay. So here, these are linear. But there's an exception to this. A might be 0, B might be 0, but A and B cannot both be 0 at the same time, because if they were both 0, 0 times x, 0 times y, you lose the x's and y's, you don't have anything to plot. But one of them, A might be 0. If A is 0, you still got a y, just no x's. If the B is a 0, you still got an x, but no y's. So you can have a linear equation with just an x or just a y. So these are the special cases. When you write the equation of horizontal lines, you see how x is different, but y doesn't change. Y is always 5. Oh, listen to what I just said. Y is always 5. The way you write the equation of a horizontal line it's just y equal to a constant. There's no x when you write the equation of a horizontal line. There's no x in it. Exactly. Because it doesn't matter what the x is. X can be any number you want. No matter what I plug in for the x, for this problem, the y for this problem is always going to be 5. That's the equation of the line that I drew right here. Y is always 5. Y equals 5. If x is negative 8, guess what? Y is 5. But where do I plug in the negative 8? You don't have to. It doesn't matter where you plug it in, because when you plug it in, you're going to get y equals 5 anyway. And that's what makes it vertical or horizontal, is because all the y's are the same. Over here, the y is changing, but x doesn't change. X is always 4. So when you have a vertical line, it's x equals a constant. Okay? There's no y in the problem. So when you write the equation for a vertical line, this equation that would represent every single point on the line would just be x is always a 4. No matter what y equals, the x coordinate is always 4. If you want to let y equal 3,000, x has to be 4. Again, this is one thing that confuses students. Here's why. Horizontal goes left and right, doesn't it?
Yeah.
So does the x-axis. So they think horizontal is the x thing by itself. Here's what here's how I help them, I think. It's not very mathematical in its language, it's just a description. If you spell horizontal with a lowercase h, horizontal. Horizontal. That lowercase h, if you use your imagination, kind of looks like an upside down y. Kind of. Therefore, when it's horizontal, use y equals a number. And when you've got vertical, An X is kind of like a V that has been placed on top of an upside down V. It's like a couple of V's that have been kind of put, back to back. And a V on top of a V is where I'm going to use vertical. For the X equals a number, it's for vertical. So whatever you need to help you remember which one is which, because it's these two special cases, there's not a whole lot of work you can show when you do the problems. The best thing you can do is make a picture of it so you know if it's horizontal or vertical. If you know if it's horizontal or vertical, then you're just doing y equals or x equals. Other than that, there's no other work you can do. The picture is what helps you figure out which one. Equations of lines, we're going to cover that next. Graphing and parallel. All right. Okay, so the 5 different equations of lines. The first one is called standard form. The standard form for the equation of a line is what I already talked about. AX plus BY equals some number C. X and Y are on the left-hand side. There's a number on the right-hand side. And most of the time, this is what they start you with. Most of the time, this is what you're handed. Most of the time, this is what you got to deal with. And then you manipulate. A lot of the time when we are trying to solve systems of equations, we like standard form. That's where we really want to use it. But for all intents and purposes, it's not our favorite. It's not the most useful when you actually want to do the linear stuff itself. But that's what standard form looks like. X and Y on the left-hand side, constant on the right-hand side. Usually, no fractions. So if you have fractions in the problem, you tend to multiply by the least common denominator and get rid of fractions. When we hit an example like that, I'll show you. The second one, they make a big deal in the book about the second one. I stopped teaching the second one a long time ago. There are 5 ways you can write the equation of a line, and I figured, all right, why give my students 5 different things they have to be able to do when there's really only one thing? If they do it well, really well, and focus on that one thing really well, they can make all the other things happen. If you want to use the second one, that's perfectly fine. Just make sure you show your work. But I won't be using it as I teach. It's called the point slope form. And when is it used? Well, the name says it all. If you have a point and the slope of a line, you can write the equation of a line. Most of the time, you're not allowed to leave your answer in point slope form. They want you to convert it into something else. And that's where I noticed students couldn't convert. And most of the time it was because of parentheses. It was this. So if you have a slope and a point, you take y minus the y value that you have, and then the slope times an x minus the x value that you were given. And when students would try to use the point slope form, they wouldn't put parentheses around this subtraction. and they wouldn't distribute the slope right. Then if there were fractions involved, they didn't want to add or subtract fractions. So I don't teach it when I do my 103 class. I show them that it exists. I tell them if they click on help in the homework for Pearson, they'll probably show this method. If they want to do it on a test, perfectly fine, as long as they show the work that backs it up. If you go to the STEM center, tutors might show it to you. That's fine. There's more than one way to do the problem. My way isn't the live all be all. Just make sure your work counts. This is the one that I want though. When I want you to write the equation of line, I'm going to want you to write your final answer in slope intercept form. This is the most useful form you can have. Because when you have slope intercept form, you automatically know how to graph the line. You automatically can rewrite it as a function. It's already in function form, function ready to go. Okay. When you write the equation of a line, and I have to grade it, there's only one possible final answer that gives me the answer. Standard form, you could have an infinite number of answers that represent exactly the same line, because all you got to do is multiply by the same thing on both sides. In other words, if I had x minus 2y equals 5, that is exactly the same as 2x minus 4y equals 10. That is the same thing as negative 3x plus 6y equals negative 15. These are all standard form. These are all the same answer as that one is. So if I had you guys write this on a test, you might give me one, you might give me the other. I got to have an infinite number of answers ready to grade, or in this case, 5 possible answers. When you do slope intercept form, there's only one way to get that answer. There's only one final answer. Because y is by itself. And slope intercept form is exactly that. You have the slope. M is the slope of the line. And this B is the y-intercept. It's where the graph crosses the y-axis. Okay. So just by looking at the equation, you're going to know exactly how to graph the line. Over here, if you have standard form, you'd have to plug in points to figure out where to graph the line. Or if you have this, you solve for y. You change this standard form into slope intercept form by getting y by itself. Get the y by itself. So if I got y by itself, just to make sure I'm on camera. Yeah, I am. I would subtract x from both sides. Be careful. When you bring this next piece down, on the left-hand side, you have a negative 2y left over. Most of the time, students forget to write down the negative. Okay. Equals. Now you're trying to make y equals, solve for y, mx plus b. You want the x and then the constant in that order. It's going to make a difference. So yes, this is 5 and then minus x. But that's not how the slope intercept form looks. It's x and then constant. So you don't want to write 5 minus x. You want to actually write minus 2y equals. It's a negative x and then a positive 5. It's a negative x and a positive 5. So just go from here straight to there. And again, I'll be doing so many examples that you hopefully will catch into. Now, here is the bad habit that I hope I can fix. On this problem, it's not going to be as evident as it will be when I do the next. Remember, we're trying to solve for what? What does the y? We're trying to put it in slope intercept form. Y is being multiplied by -2, so you're going to divide by -2. This is the big mistake people make. They do this, divide the whole thing by -2. That's not a mistake. That is absolutely correct. That is perfectly right. But the next move they make is usually make a mistake. They can't simplify what they just did. They don't do it correctly. They don't put the pieces up, or they don't show the work that justifies it. Remember, you're trying to figure out the slope and then x and then the constant b. You want to know what these two things are separately. So instead of dividing the whole right side by a -2, if I divide one term by -2, everybody gets divided by its own -2. It's kind of like being at that last Oprah show. Last Oprah show. You get a car, you get a car, you get a car. You get divided by -2. You get divided, everybody gets divided by -2. If you divide one, you divide all. Okay. So now I have y equals a negative over a negative is a positive. So I get x over 2. And then I have a positive over a negative, so that's a negative 5 over 2. Real quick. One of the things you're going to want to know and be able to do by looking at this is what's the slope, what's the y-intercept, because that's the whole purpose of doing what I just did. So what we just did was to get y by itself, we're trying to figure out mx plus b. It's like going down to the police station, looking at a lineup of potential suspects who stole your backpack. And they're all lined up and you're trying to pick out who the M is and who the B is. So what's my slope? The slope is not the x, it's only the coefficient in front of the x. So you never put x as part of your slope, just the number in front. So if I had like, y equals 4x minus 8, the m would be a 4 and the y-intercept is a negative. So what's the slope? It's not being multiplied by 2.
0.
If it was 0, then 0 times x would be no x. But what else? Here, good. This is why I'm asking. X over 2 is x divided by 2, right? Which means it's x times the reciprocal. Now, this is 2 over 1. So the reciprocal is 1/2. When you divide by 2, you're taking half of something. So it's x times 1/2. Now, multiplication is commutative. I can switch this order, and I can just write this as 1/2 x. Or, yeah, you have one. This is a 1 times an x, isn't it? So technically, I can extract that 1/2 times the x minus the 5/2. Okay. So the slope is 1/2. And the y-intercept is -5/2. Now, this one. 2x minus 4y equals 10. Supposed to be the same line, but let's see if I get the same thing if I get y by itself. Solve for this y. So I'm going to subtract 2x. On the left side, -4y equals -2x, and then plus a 10. And then to get y, everybody gets divided by -4. Now, this is y. I hope you don't do this anymore. Because when I see students do that, they start crossing things off. Over here, it really didn't work with you. You went to -x plus 5/2. Nothing, you can't cross anything off, you can't reduce it. But here you start saying, hey, 2 goes into 4, and then hey, got 2 left, 2 goes into that. It doesn't work that way. If you're going to reduce, you either have to factor and then reduce, or you split the fraction. You split it into separate fractions. So what I'm doing when I do divide each one by -4, what I'm doing is I'm actually splitting the whole fraction into 2 separate fractions and then reducing each one separately. A negative over a negative is a positive. 2/4 is 1/2 x. A positive over a negative is a negative. 10 over 4, the common factor is a 2. 2 goes into 10 5 times, 2 goes into 4 twice. It's -5/2. The same equation as before. But that would be a correct answer if you hadn't put it in standard form. But if you have to write it in slope intercept form, there's only one final answer. Over here, add 3x. So you got 6y equals 3x minus 15. Everybody gets divided by 6. Uh-oh, sorry about that. A little evilness around. You get y equals 3/6 is 1/2 x minus 5 goes, sorry, 3 goes into 15 5 times, 3 goes into 6 2 times, minus 5/2. Most useful one. It'll also be, in my opinion, easiest one to write equations of lines with. I think. I like it a lot. All right. And then our 2 special cases. We have horizontal. And we have vertical. Slope on horizontal is 0. And when you write the equation of a line, it's y equals a constant. There's no x in the equation. It's just y by itself. When it's vertical, the slope is undefined. And when you write the equation of a vertical line, it's x equals a constant. And there's no y in the equation. All right. Oh, we didn't take our break. Okay, so with what we know so far, let's kind of take a look at some of the homework. So number one is matching. Basically, what I just went over there is the 5 different ways to write the equation of a line. Now, if you look at this first one, that C is on the wrong side. AX plus BY should equal C. And then, oh my gosh, this is something you'll learn in calculus. Okay. You have for standard form, AX plus BY equals C. That C represents a constant. We don't know what the constant is. We don't know. So over here, A, that constant's on the left-hand side. So to bring this C over to the left, I would think you'd have to subtract it. So shouldn't it be AX plus BY minus C? Well, here's the deal. I don't know what C is. C is a constant. C could be positive, could be negative. It's just a number. So whether it's on the right or the left right now, we don't know what it is. It's just some number. It's a constant. So whether it's on the left or the right, it's still a constant. It's not a horizontal shift. It's not a vertical shift. It's not anything. It's just a number, whether it's on the left or the right. So instead of using the word standard form, we use general. So that would be free. Or that we choice I. Okay. And the other ones are very subtle.
So then we can just put the letters in for it.
Yeah, there's well, it's matching. It'll work. Yeah. You don't have to write it out. In calculus, we do something called integration. When you integrate, you get a constant of integration. And sometimes you have two integrals and you get a constant plus another constant. And C plus C is C. Because it's just, what's this constant? I don't know. What's this other constant? I don't know. When you add those two constants together, what do you get? Another constant. It just represents some constant that we just don't know. It's not a variable, so you're not getting 2C. What would 2 times a constant be? A constant, so 2. And that'll be explained when you do it. All right, so 7 to 23 odd. So number 7, you have 3 different lines. You got line 1, you got line 2 going this way, line 3. So which of those do you think is a positive slope of 2/3? 1, 2, or 3? Line 1, line 2, or line 3? Which one is the slope of 2/3?
I would say L2.
Line 2. L sub 2. And then which one looks like has a slope that's undefined?
Line 1.
Line 3, that's the vertical. And then -2 would be the one that falls. Yeah, you don't have to do any work because you're just writing the answer. It's a picture. Nine, estimate the slope. They don't give you any points, but you know what? You can estimate because you know rise over run. If I estimate, let's see, I'm right about here. And you don't even have to use the slope formula. How about just rise over run? The rise is up 3, and the run is over 2. That's what they mean by estimate. And I don't want you to, again, not trying to offend anybody. Yes, am I holding your hand through a lot of this? Yeah, because this is not a high school algebra textbook. This is a college algebra textbook where the directions don't always tell you what you're supposed to be doing. So I'm trying to help you. I mean, people get stuck on, what do you want from me? So I always wish somebody would have walked me through homework, because they would just lecture and say, good luck. And 11, you're supposed to, it says plot the point 2, 3, and then on the coordinate axis, graph a line that goes through that point with a 0 slope, that has a slope of 1, that has a slope of 2, and that has a slope of 3. Negative. So you're just drawing one picture, one coordinate axis that has 4 different lines on it. Now I did this one for the other class yesterday. It goes through 2, 3. And I'll just demonstrate A and D. No, I'll do A and C, and then I'll talk about D. And so 2, 3, over 2, and up 3 is right here. Always label. When I ask you to graph on anything, I always want you to label points. If it's on an x-axis or a y-axis, you can use it like a number line, just one number. If it's in a quadrant, like this is, I expect to see the ordered pair, 2, 3. So the first one is slope of 0. So 0 is horizontal. So I'm supposed to draw a horizontal line. Anytime I ask you guys to graph a line, if it's linear, I have to see 2 points that are plotted. There's one, and I know you could just take your straight edge and draw a horizontal line, call it good. I know that. I want to see you plot and label 2 points. So all I'm asking is for this. I just need another point side to side that's on this line. Tell me when to stop. So if I stop right there, it's horizontal. Label, this over here is -3, +3. And now I have a second point labeled to draw my line through. And whenever you graph a line, make sure you put arrows, because lines go in both directions forever. Okay. So that's part A. Part C set a slope of 2. So I might even label it, this is a slope of 0. C is a slope of 2. So from this point right here, a slope of 2. Now, okay. Rise over run. Well, that's only one number. Every real number is rational. Right? Actually, I just messed that up. Every real number could be written as a rational if necessary, even the irrationals. If you have square root of 2, you can make a fraction out of it, square root of 2 over 1. But an integer, you can make a fraction out of an integer because you need rise over run. As a fraction, this is 2 over 1. Okay. The rise is 2. So from here, you would go up 2, and the run is 1. You go over 1. So from this point to get to the next point on the line, you go up 2 and right 1. Label that point. That point is at 3, 4. Oops. 3, 5. Graph my line through there. The slope is how you go from one point to the next point. It's not the location, it's not the ordered pair. The slope is how you got there. The ordered pair is where you are. So I went up 2 and over 1. So where are you is the address. If I go and maintain that slope and go up 2 and over 1, now I'm going to be at 4, 7. I could go down 2 and left 1. If I go negative over a negative, that's a positive slope. But now I'm at 1, 1. All of these are like a staircase. They're all in the same line. But this is my slope of 2. Part B said, what is, we want a negative 3 slope. So what would negative 3 look like as a fraction? Negative 3 over 1. So from this first point, you would want to go down 3 and then to the right 1. Down 3, right 1. Anytime I have a negative slope, I need this guy. We'll always put the negative in the numerator. See, a negative slope means you're either going to go up, but you have to go left, because you have to have a negative direction. If the slope equals a negative, that means you either have a positive over a negative, or you have a negative over a positive. When the slope is positive, you're going to go up and right. You're going to go to the right. If the slope is negative, I prefer to put the negative in the numerator, so then I'm going to go down and right. I'm always going to go to the right. My denominator, my run is always going to go to the right. That's just what I, again, works out, but it will work out no matter what. Down 3 over 1, and if you look at it, it's on the x-axis. When you're on the x-axis, you can just label it like it was a number line. You use one number. You don't need an ordered pair. If you do use an ordered pair, make sure you put 3, 0, not 0, 3. Don't get them mixed up. Draw that line, don't use arrows. This slope is -3. And just to point out, if I would have went +3 up and then -1 left, so from here, 1, 2, 3 up, but 1 to the left, it's still on the same line. Okay. On number 13 and 15, don't worry about doing the graphing utility one part of it. It says, find the slope of the line passing through the pair of points, then use a graphing utility. So just plot those 2 points and draw the line. Okay. Okay, here we go. Write the equation of the line. So use the point on the line and the slope of the line to find, oh, never mind, we're not graphing, we're not writing the equation of the line. Let's go for 23.
So 17, you plot 2, 1.
It's horizontal, and there's more than one answer. You got to find 3 other points that are also on the line. There's an infinite number of points on the line. You could find out, but the slope is 0, so you just want horizontal. As long as the y is 1,
Yeah.
But 23. -7, -2, and the slope of 1/2. So the ordered pair is 7, -2. And the slope is 1/2. And this is why I made all that graphing paper for you. Is it's going to be so much nicer if you use the graphing paper grid to draw things. So 7 over and then down 2. So there's the point. 7, -2, ordered pair. And then the slope is 1/2. So you would go up 1 and over 2. Up 1 over 2. Automatically, they want to find 3 more points. There's one of them. That ordered pair, x is 9, y is -1. So there's 1. We're supposed to draw the line. Now, if you're sloppy, if you're not paying attention to what you're doing, it'll be very, very bad news. Lots of bad news. But luckily, you can always count. Up 1 over 2. If I go up 1 again and over 2, that puts me at x equals 11, y is 0. If I go up 1 and over 2 again, that puts me at 13, 1. I could have gone down 1, left 2. Also, a possible answer would be x equals 5, y equals -3. Down 1 over 2 to the left. X is equal to 3, y is -4. These are all possible answers. That's why we're saying there's many possible answers. If you want to be cute about it, you could even do this. All right, so we're at here first, 7, -2. And let's go up 1/2 and over 1. So x would be +8 and y would be -3 over 2. Or -1.5. Because it's also on the line. All I did is instead of going up 1, I went up 1/2 instead. So if I go up 1/2 in between -2 and 1, that's -1.5. And then over 1 only, so if I'm at 7, I went over 8. It's there. Here we go. Find the equation of a line. So your quiz, should you choose to accept? Yeah, you have. Your quiz is going to be write the equation of a line in slope intercept form. Now, I am not going to do enough of these examples, in my honest opinion, for you to take the quiz on Monday. Your quiz is going to be Wednesday. Don't tell the other class. They're taking theirs tomorrow. But and that's just the way it is, because they finished going over at least the homework, the examples yesterday.
You just have to find the equation for slope intercept form.
For slope intercept form, these are very straightforward. Okay, when slope is 0, that means it's horizontal. 31. Horizontal line to 0. That means y equals a constant. So what does the y equal? 3 over 2. That's it, done. If it's undefined, that's vertical. So x equals a constant. What does x equal? It equals a 6. Okay. 27. So this is how I actually explain how to write the equation of line. Here you're given a point, 2, -3, and the slope is equal to -1/2. So obviously, hey, you're giving me a point and you're giving me a slope. So I should be using the point slope form, which is would be great if I choose to teach that and I don't. The answer needs to be in slope intercept form. So your final answer needs to look like this. This is what you're at. If you use point slope form, and plug in everything into this, you have to convert this into that. And that's where I see students, at least at the class below this level, they can't do it. They just they can't keep up with all the steps. So I line this, lay this out step by step. Step by step, first step. Step number one, find the slope. The first thing you have to do to write the equation of line is you have to find the slope. Oh, look, I found it. Sometimes it's given to you. Sometimes you're given two ordered pairs. If you're given two ordered pairs, then y sub 2 minus y sub 1 over x sub 2 minus x sub 1. You have a slope formula to calculate the slope. Sometimes it's just described in some kind of written presentation. It's parallel to something else, it's perpendicular to something else, which is what we'll get to on Monday. And then you can interpret how to find the slope that way. But you got to find slope first. Slope is what you do. Because what you're trying to do is, this is a puzzle. And you have to find the two pieces and put them in the puzzle. You have to find the M and the B, and you got to plug them in and you're done. So step one, find the slope. Okay, we found one of the pieces. It was given to us. The next thing you do, step two, is it a special case? Because if it's a 0, or if it's undefined, your slope, then you don't need to do the rest of the steps. It's just x equals a number or y equals a number because it's horizontal or vertical. If it's a special case, you basically just, the best thing to do is, if you're confused, make a sketch. Because the rest of the steps won't help you because you can't plug numbers in. If the slope's undefined, you can't plug undefined into something. You can't plug undefined in for m, it won't work. So if it's horizontal or vertical, then make sure you know which one it is. It's either y equals or x. If it's not, continue on to step 3. And I get real OCD about this. I'm just going to say, I'm going to write down the slope intercept form. Remember, I said this is a puzzle. When you do a puzzle, you put all the pieces out on the table. Turn all face up so you know what you're looking at. And then you put the box away in the closet. No. You leave the box on the table so you know what the picture looks like, so you know what you're trying to make. If I'm trying to make a puzzle, I'm going to write down what it is I'm trying to make. I'm going to write down this y equals mx plus b because that's the picture I'm trying to complete. That's just step by step how I try to keep track of it. One thing at a time. Step 4, substitute. Substitute is a fancy word for saying plug it in. Substitute the slope. Plug the slope in. So y equals -1/2 x plus, we still don't know what b is. But we're almost done. I mean, honestly, it takes longer for me to just talk it through than to actually. But we gotta find the last piece of the puzzle, which is B. So look at what we have. We need to figure out B. There's three variables right now that we don't know, three unknowns. Y, X, and B. If you have three unknowns, to figure out one of them, you need to plug something in for the other two. If I can plug something in for this X and Y, then I can figure out what B is. If I only knew an X and a Y, that is on this line. That's what's given to you.
That's what you do, right?
Yeah. So after you plug in the slope, step 5, substitute. A given X and Y to solve for B. The only X and Y that I know of is this 2, -3, so I'm going to let, remember that's X, X equal 2 and Y equal -3. Now don't mix them up. This Y is the -3. -1/2 times X is +2 plus B. So I solve for B, simplify this before you do it, -3 equals negative times a positive will be a negative, 1/2 times 2. 2 goes into 2 one time, so -1 times 1, that's -1 plus B. Add 1 to both sides. -3 plus 1 is -2. So that's what our B is. And then step 6, write the final equation. So the missing y-intercept that we needed, this B right here that we were trying to figure out, I now know that it's -2. So y equals -1/2 x minus 2. And that's the equation of y. So instead of plugging it into point slope form and then having to solve for y, when I figured out using slope intercept form, I'm done because I have it. All right. We're going to do the roll. Oh. 1, 2, 3, 4, 5. Everybody's here. Do it all. Amazing. All right. So that means I went over, basically through 31. So if you can try to attempt to do through 31, that would be awesome. And we'll continue going over homework examples after that on Monday. All right, you guys. Have a great weekend. Be safe.